Good afternoon, everyone. It's good to be here. How are you? It's good? Energy is good? Right. Excellent. So today I want to talk a little bit about multi-region things. Let me start the whole presentation. Yep. It's good. So why I'm talking about multi-region, there's a couple of things. It's just because I think in my career, it's probably the one thing that totally fell in love is the story really started in 2012, the eve of 2012, Christmas Eve. And Netflix went down a few hours, and they couldn't do anything about it. Actually, at that time, Netflix was only in one region in the US. You might not know, but Netflix runs on AWS. And back then, they had only one region in US East. And US East, in eve of 2012, the ELB data plan went down for a few hours, and they couldn't do anything. We fixed that, though. But at that time, they went down for a few hours, and they kind of really felt bad about it. And they went into a journey of having the first multi-region active-active backend. And at that time, they created a new region in US West, and being able to do an active-active. And active-active is very different than active-passive. It's obvious, right? But an active-active means that any users at any given time can actually hit the backend regardless of the region, right? And that's super difficult to do, especially considering the time, 2013. There was not so many managed services. Databases were not as good as they are now. People still had to do a lot of bin-log replication across multiple regions, make the synchronization. The networks back then went over the internet. The internet latency is not as great as you can expect. So they went into this, and it took them really a few tens of people, several months to build their first active-active region. And they continue, actually. In 2016, they expanded that multi-region into Europe, right? So now they have 3 active regions, which is quite a phenomenal achievement, if you ask me. It's one of the only customers that is able to do this at scale. It's very, very difficult, but it becomes easier. And today I want to talk about how to do this in 20 minutes, okay? So that's a challenge. So why do we do this, actually? And you probably understood quickly why do we do this. The first reason is mathematics. Actually, this equation just stipulates that if you take 2 parts of a system and you put them in parallel, the overall availability of the system increases dramatically. So if you have 99% availability, a system that is 99% available, but you duplicate that, it becomes 4 nines. If you do this 3 times, it's 6 nines availability that you get, which, if you ask me, is pretty good. It's pretty hard to achieve. And you don't have much to do on the application. Of course, you have to deal with the state of the application being replicated across regions and things like this. But that's pretty much the only hard things that you need to do. So the other thing is we've become very global, right? So 10 years ago, we still were building applications for our local markets. Nowadays, it's very common that we have users all over the world, right? And latency is crazy. In fact, we did some tests at Amazon.com, the retail side, and we noticed 100% millisecond latency increase on the UI generates 1% drop in sales. At the scale of Amazon, it's massive. If you're able to recognize and to go as fast as 100 milliseconds, I want to meet with you, because most normal humans can do 0.6, 0.7 of a second. So we are not consciously aware of 100 milliseconds, but the unconscious human actually has a massive effect on the latency. So 100 milliseconds, a 1% drop in sales. So having global backends is very important, especially for global companies. And now most of the customers are looking at having backends closer to their end users. It was common to have CDNs, so static content and things like this. It was quite normal to have this already closer to the end users, but dynamic content was a lot harder to do that. So that's why backends now need to go to the closer to the end users. And often people combine that with disaster recovery. And I was talking about active-active. So the traditional passive-active is actually a disaster recovery scenario. But you can do this as well in active-active. And in fact, that's what Netflix does. And they practice this once a month. In fact, once a month, they purposely destroy an entire region on AWS for their application to practice moving all the users to another region, right? And they do this through chaos engineering. So this is a very good way to do disaster recovery. They don't do this in 1 second. In fact, it takes 10 to 15 seconds to shift the entire traffic of a region to another one. They do this through service degradations. There are a lot of techniques to degrade the APIs, to make sure which are the critical, the non-critical, make sure that some of the backends eat the cache instead of the dynamic content. But in 15 minutes, they're able to shift the entire traffic from one region to another. And disaster recovery, very often people think that an entire region go down is often not the case. It's really a critical service, right? That, for example, you have a master database in one region, and you say, oh, OK, we can't write into it, so we degrade into a read-only mode, and then shift the traffic to another region, so that 15 minutes after we can have another read-write in full region. So this is kind of things that customers are doing nowadays. But you have to realize that the cost of shifting traffic as well is very, very high, because the blast radius gets much bigger. So you don't necessarily flip the traffic from one region to another at the first sign of a problem. Very often, it's a very tight compromise between how many errors do you see and how fast do you react. And there's no silver bullet for that. It's actually very depending on the customers and the application. But it's a fine art to find this balance. So the traffic then eventually shifts. And there's few things you need to do multi-region architecture. The first thing, which is always most troubling, is understanding this theorem, which stipulates that in case of partition tolerance, you can only have either consistency or availability. You cannot have both at the same time in a distributed system, right? That's because the speed of light, right? Unfortunately, no one managed to solve that. So the time it takes to replicate data between nodes prevents you to be consistent. In fact, we say that a consistent system is usually has to be under 5 milliseconds. That's this really the limit, right? So if we want to have multi-regions, we have to go for availability. And if you go for availability, you have eventual consistency coming into the picture. And this is actually something you need to take into account when you design the UI, the backend, the APIs. It's not just a myth. It's actually taking into consideration a lot of things. It's probably the most important thing to take into consideration when you go multi-region. And often people forget about that eventual consistency simply means that if I request the data twice, I might get the different answer, simply because the data is not necessarily replicated in all the nodes. It's not converged yet. So that means, how do you build UIs that actually hide this from the users? How do you build APIs, independent APIs that hide this as well from your backend? So there's a lot of strategies here to do that. In 2017, we announced globally that finally you didn't have to go across the internet anymore. In fact, this is the global Amazon-owned network that goes around the world with redundant 100 gigs lines. So now, when customers do multi-region, it actually doesn't go over the internet, so we can control the latency and the packet error loss a lot better. So now we can do a lot more efficient things. And this is why, for the last 2 years, we started to see a lot of new services and product going around the multi-region support. And we are not stopping there, in fact. And today, you can do this serverless, actually. This is an architecture you can build in 1 hour. I've pushed all the code on blogs and GitHub. And I'm going to do this demo in about 11 minutes once I'm done talking. It was done possible by two things. One of the new updates we've done on API Gateway, one of the services we have, is that we support custom domain. Of course, when you go global, you want to have a global domain name. And if you don't have custom domain name on your APIs, then you don't have a consistent CNAME. Now it's possible, so you can directly target the regional endpoint. So that means when you deploy, you can assign your domain name. When you do this, you can also now start using a feature called global tables on DynamoDB. And DynamoDB is our NoSQL database. We went into designing NoSQL database in the mid-2000s when we realized at Amazon Retail that 70% of our queries on Amazon.com were non-transactional. So we thought, why are we doing transactional database? So we started to develop DynamoDB. And now it's available for customers. And we launched a feature a year ago called Global Table. And this is a multi-master, multi-region. So that means you can have a global table around the world that is fully managed, that will do all the conflict resolution for you on when you insert data in different regions. We use the last writer wins kind of conflict resolution. It's quite simple, often used in many of the distributed applications. But this is the core of the systems. In fact, this year we're also launching a transactional version of the multi-master on Aurora. So Aurora will support multi-master and multi-region, but currently it does not. So this is at the core, right? And of course, you have to have a global routing as well. So these are the kind of strategies you can do on routing, whether you want to have latency-based routing. This is really figuring out how close your user is to the backend. If you're regulatory, this is not necessarily the best routine. What you want is really to use geo-based routing. Simply, if you have your user in Europe, you might want them to hit the backend in Europe, and vice versa with the US or Asia, other regions. And this is used very, very commonly by many of the large customers that do geo-routing. So Instagram, Facebook, Google, Amazon all use this kind of geo-routing so that they can also do sharding on the database based on the geolocation. But this is what happened. This is the one I'm going to use for the demo. It's a weighted round robin. It means that we just send the traffic depending on the weights. Very often it's 50-50 between the two. So that means in the long term, we're going to have 50% of the traffic going from one backend to another. This is the kind of things that are done. And all this can be combined with DNS failover, which I mentioned. In case there's a service disruption in one region, we flip the entire traffic all over. And hopefully I have time to demo all that. OK. So a couple of things that actually people always ask. How do we test multi-region architectures? We don't do this through unit testing or functional testing. Actually, you have to employ a new kind of paradigm shifting. At Amazon, we use something called game days, where we randomly break things in the architectures. Sometimes we break data centers. There's actually a guy called Jesse Robbins who was a firefighter, came with the idea that we need to practice fighting live fire to be able to have this intuition to support outages. But Netflix does something called chaos engineering, which is very similar, and they have those monkeys, which are the tools to test their backend, which are across multi-region. The last one, the big gorilla, is actually this monkey that breaks randomly regions on their environment, once a month, roughly. So let me show you a code, because I think this is what's important here. So let me swap the displays. Cool. So this is the Lambda functions I'm gonna use. I have a bunch of Lambda functions to do the code. This is just one to get data from DynamoDB. I have one to post data in DynamoDB, and I have a health check here. As you see, it's a very, very advanced health check. I return simply a code based on environment variable. This is exactly to test the DNS failover. This is what I want to show you today, how fun it is to break region. And this is simply deployed with the serverless framework. These are the 3 APIs that will be deployed. On the backend side, there's a couple of things that are done. So I have a global table in DynamoDB. I'll show you. there. I'll show you quickly how this works. All right, so I have a table here called global2. This is my global table, and as you can see, it's replicated between two regions in the US, between Virginia and US West. If I want to add a region, it's quite simple. I can select the region and just add it there. So yeah, I'll just do it like this, live. So what you can do is, when you create a table, is simply add the global table features. It's really like 30 seconds step to do that. And when you do this, okay, it's applying the settings. Up. Yep, done. All right, cool. So now I'm replicating my data across 3 zones, so I can create an item, and I'll say just like, so I have my item that is being created here, and then I can go into the global table here and see it happening in other regions. So I have my item now that's been created in West 2, and you can also have it, of course, let's go into the last one, into Ohio. So it's quite straightforward. It goes over, the replication goes over our network, so the latency is very limited by the speed of light. So that's pretty good. Okay. So I have my items now replicated across 3 regions. I want to show you quickly the architectures again. So I have my Lambda functions. I have an API gateway in each of the regions, and they both store data into a global table. Each of those API gateway have regional endpoint, which I will target with Route 53. Route 53 is this DNS provider, which also has traffic policies. So let me show you what it does, a traffic policy. A traffic policy looks something like this. You define your endpoints. There, and you see I'm using weighted rules, so 50% of the traffic will go to one endpoint, 50% of the other will go to the other one. And I also have a target health. So this is the interesting thing, and it's also the one that is very difficult to do when you go in production, is creating the health check for very large distributed systems. There's 2 types of health checks, shallow or deep. Shallow is very good to figure out the network connectivity issues, and deep is to figure out the dependencies. So a deep health check will hit the backend, and the backend will ask all the dependencies, are you okay? And are you able to take traffic? And this is where graceful degradation is very important to think as well, because if, for example, your service uses a notification system or a mail server, but it's not critical, and your API health check returns not okay, it's going to be taken out of the traffic. So you need to have very intelligent systems, way more intelligent than my Lambda function that returns just the code. So I don't have too much time in 20 minutes to talk about all the implementations here, but this is how the functions look like. So again, I want to show the health check, and then I can go into the console and say, for example, to my Lambda functions that don't return anymore 400. So you see the health check. Where is here the health check? Here is healthy because I'm returning 200. Okay, so I have a healthy. I'm returning 200 in all my traffics. But I'm gonna now switch this to return 400. So let's do that quickly. And while doing this, I will also launch that. So here I'm posting data into my global table, about 70 items, and I want to see where they are being created, because ideally, as soon as my health check is going to fail, all the backend systems should be able to fail over to the unhealthy or to the healthy instance, right? So here you'll see the health checker is going to start to get data. Okay, so now we're already returning 400. There's different type of health checks. There's the long one, the short one, depending on how critical your backend is. But this is the kind of things you can do. As soon as 18% of the health check around the world return 400, we declare the instance unhealthy. 18% was just found out as simply because we have health checks in 6 different regions and 3 availability zones. So we thought that having 18% of that would be a very good way to determine whether the system is healthy. And you see now my system is unhealthy, so all my traffic can be moved to one region. And then when you do this, you'll see what happens on the system. Let me push this up. When you create the items in the data, they have a new field that is being added in the table called update. So this is the location where the data has been put in the database. So now you can see all my items are actually being pushed from the region west. So it means my failover has been working pretty okay so far. And you can do a lot more kind of sophisticated systems, but this is. I'm not sure if I managed to convey the challenge here, but really, like when Netflix did this, it really took them about 4 to 6 months to have a full active backend, and now in a couple of minutes we can set up systems like this. So the leap forward, especially in serverless, is quite dramatic, and we have lots of customers jumping on this now, being able to go global in minutes, and this is pretty insane if you ask me, especially if you've done database replication at scale. It still blows my mind that in less than 1 hour we can do architectures like this, and hopefully it gives you enough interest to have a look about this. If you want to read more about all that, I've published. I'll push the slide, but I've published a long series of blog posts on Medium. If you want to look at it from all the resilience sides and then how to do this serverless and inside of VPC and all this kind of stuff. Well, and I'm here, so you can also ask me questions if you wish. Thank you very much. Bye-bye.